Hello, Richard.
Hello, Robert. You okay?
Yeah, I'm just waiting for Keith to join. People are joining us now.
I'm not sure why I've come on and do video.
Well, you're obviously famous. You're broadcasting, and the number to an increasing number of people I can see who are coming on early.
I'll dip out then for now. I'll speak to you
Fourth
later.
in our series. So good morning, good afternoon, good evening to those who are currently joining us. Just need to get Keith online. Just waiting for today's star of the show, Keith Costle, to join us. I can see an increasing number of you there. So hello to you all, and hope you're all well. It's 3 minutes to go. Obviously, everybody's very keen this week. This is a much earlier joining than we normally expect from people, but it's lovely to see you all there. I hope all your airports are well and you're actually managing to start some form of operations. Good morning, good afternoon, even Felicity. If you could just give Keith a quick call. I see he's not joined us yet. Hopefully we don't have any technical issues with Keith today. Those of you for a couple of weeks ago will recall that his internet failed, and we had a significant period of you having to listen to my ad-libbing, which hopefully you won't have to put up with today. We had another surprisingly busy week in the UK. It seems that increasing numbers of you are being able to get airside and are preparing for resuming normal operations. Today's seminar, Keith will be recapping briefly over what we've done the last couple of weeks. We'll be talking about operational needs, we'll be focusing on technological advances, and then wrapping up with safety, competence, and electrical safety, competence, and compliance. So there we have Keith, today's star of the show. Welcome, Keith.
Hiya.
Good. We've just got a minute or so before we start. It's not 2 o'clock yet, but I see we have a number of, 50 participants online already. So thank you very much, and I really appreciate your enthusiasm for what we're doing here. We hope you find it useful. Please put through any questions, which I will pick up and try and feed through to Keith at the end of the webinar. I was just saying, Keith, that you'll be doing a bit of a recap today, focusing on operational needs, looking at technological advances, and then finishing up with electrical safety and how they are inseparable from safety and compliance. So
yeah, very much so, Robert.
So yes, so right, we're just about ready to go then. So what I'd like to do then is kick off today's seminar. Good afternoon, good morning, good evening, whatever time of the day it is. I see we've had participants from from as far apart away as the Antipodes, so the Australia, and we've had right the way across the Far East, Middle East, Europe, and the Americas. So we're pretty much, I don't know how you're doing it all, because some of you obviously in the middle of the night or very early in the morning, but we really do appreciate your participation and interest in what we're doing here, and we hope you're finding it useful. my name, who I think you probably most of you know me by now, it's Robert Shapton. I'm Managing Director of TMS Training Solutions. I'd like to welcome you all and wish you all and your families and colleagues well. Our mission here at TMS Training Solutions is to provide competence-based training for the next generation of aviation professional. And there's none better to help you with this than Keith Costall, who will be leading today's webinar. The objective of these webinars was to focus on regulatory requirements, safety, competence and compliance in our fast-changing environment. Never faster changing than with the unexpected events of that unrolled right at the end of last year and have turned into a full worldwide pandemic with major consequences for our industry. I don't think many of us last Christmas could have imagined what the situation we would be in at this time this year. But we've got to make the best of these things, and we're trying to help the process. We're going to try and help the recovery. Our task is to make sure that when aviation does return to normal, that our aprons, taxiways and runways are well maintained, that we manage operational and safety risks ready for restarting operations, that risk mitigation processes are in place for those events that will inevitably surprise us at the last minute at the worst possible time. And key to that will be the provision and the execution of planned preventative maintenance to make sure that we're ready. So this week, Keith will be focusing with a bit of a recap on what he's been talking about the last couple of weeks, then talking about operational needs, and then going on into technological advances. So without any further ado, I'd like to hand over to Keith now, who I'm just sharing my screen with. Keith, just hand over control of the system. Okay, Keith, you should be able to do your stuff now. I'll hand over to Keith now, who will take you through this week's week 4 TMS Training Solutions webinar. So thank you very much, and over to you, Keith.
Thank you very much, Robert. Here we are. And hopefully you can see my screen. Can you see my screen yet? And you are muted.
So just whilst Keith battles the technology there, yes, if we can, as I said, we'll be looking at Keith. We'll be looking at operational needs, because obviously what we do here is. Are you looking for have you got the presentation there, Keith?
Yes, I have. Right.
So you can get in full screen mode, or do you want me to put it on my screen?
Well, let me once again. You seem to have. Can you hear me? Eh?
We can hear you all. Yes.
Okay. For some reason, my screen share it said okay. It says I'm the host, but it doesn't come up very well. So we'll have to try again.
Okay.
Sharing my screen. You need to you disabled host as disabled screen sharing.
Right. Are you okay there, Keith?
Okay.
Sorry about this, ladies and gentlemen.
There we are. Hopefully you'll see it.
We won't give up the day job.
Can you see my screen now?
Yes, we can, Keith.
Okay. Sorry about that. Hello, good afternoon to everybody here in Europe or Africa, or going west, good morning, good evening, and going east, good morning, whatever it is for you. So as Robert has said, what we're going to do in this webinar is really to, if you look at the screen now, you will see we're going to continue with step 2 and then onwards to step 3 of our webinar series. And I will be dealing with lesson 5, 6, and then step 3. And we're also going to give you a question and answer session at the end, but we'll explain a little bit more about that later. So without further ado, let's just remind ourselves what we are really talking about in terms of AGL, in terms of our runways and our taxiways, is they need to be operated safely, and the equipments need to be compliant operationally and with standards. And we as people, whether we are a designer, whether an installation contractor or a maintenance contractor, etc., or even a consultant or even a regulator, we need to be competent. We need to have a competency level associated with our job function. Therefore, we need to have knowledge, skills, and of course, the correct attitude. I'm going to very quickly show you these. I showed you these, and I'm not going to say sorry for showing these. This is an HV, high voltage injury. And we have high voltage for safe working procedures is anything above 1000 volts. And that's what we have in AGL. So please think of it and remember, if you disconnect a live electrical circuit of a traditional 6.6 amp AGL circuit, you could be killed. And these are a few little injuries associated with high voltage electrical burns. And we don't want this to happen to you. Unfortunately, many people have been killed their side, and we don't want it to happen. So just think about these hazards. Going onwards, we are going to be really concentrating this time on surface movement guidance and the technologies associated with surface movement guidance that follow the green technology, basically, which is known. We are part of the CNS, the Communication, Navigation and Surveillance package within the airport operations. And it's that element that we're going to really have a look at. So the questions I asked from our previous webinars is, can you work safely airside? And do you really understand the AGL and the technologies now? Because the technologies are changing. We're no longer just changing the bulbs on the airfield with power supply technology, with the changing of CCRs to high frequency and or transistor-based CCR technology. The field circuits, we've migrated really from tungsten halogen to the LED world. That's brought its own challenges. And in remote control is where the advanced surface movement guidance and the individual light control and monitoring has come in. So do you have the knowledge? Do you have the skill for these technologies? So just to remember, AGL is in 3 basic packages: power, control, and the field circuit lighting. And this is what it looks like. So just to remind ourselves and get us all on the same wavelength. But remember, our function is to provide, to commission, and to maintain and operate an AGL system, a visual aid system for pilots. And basically our AGL is made up of, electrically, is made of the primary circuit, which is the dangerous part, because the voltages could be up to 4,545 volts, maximum at 6.6 amps. And remember, voltage burns, current kills. The secondary circuit is the low voltage side, but if we have a short, electrical short between the primary and the secondary, then the voltage on the secondary is at the voltage of the primary circuit. And therefore, we do also have some additional components such as earthing networks or a counterpoise earthing network, which is for lightning protection. So let's go on to these operational needs and the technology changes associated with AGL, because as Robert said, we're in a fast-moving world, and I really want to discuss it because operationally and technically, AGL has changed. And we have a little video that we showed last week, but I'm going to show it again, and it really brings it into perspective. So I want you to have a look at this little video, and you will find that it's interesting.
Number 143. Noticing 181 Flight ships are replicating with this translator. Flight ships are along with 4 levels to the hotel.
Just a small video to bring us into reality of what we're talking about. So we have really moved from a traditional AGL system, and to be able to produce this kind of technology, we need to have individual light control and monitoring. And in individual light control and monitoring, then we really started with either power line communication or a separate communication to remote switches. And today's technology, some of that has been included into the light fixtures. But certainly, this is the way forward. But as explained previously, one of the issues that has created issues for this kind of setup in individual light control and monitoring is the reliability of the 6.6 amp system, because there are lots and lots of connectors in an AGL system, all living in the ground and in a hazardous environment, including underwater. Then these are probably the most single point of failure in the standard system. And if you're trying to communicate across those connectors, which have electrical problems, then etc., then potentially, then we could lose the capability to have individual light control and monitoring. So just to bring it into perspective for us, in reality, out in our airports. Prior to COVID, traffic density was a major issue, and many airports around the world have been looking at being able to increase their traffic density by the use of individual light control and surface movement guidance. And what that does is, as you showed here, but with individual light control and monitoring, then we can switch lights off, either in blocks of lights or individual lights. And in fact, over the last 2 or 3 weeks. This was a webinar where these lights, which have been switched off previously, apparently now these can change from green to red. Whether that, they have regulatory approval yet, but the concept is quite interesting. And of course, this enables us with ILCMS to be able to have more control of the lights and more traffic in our taxiway network. Basically, I showed this last week just to remind ourselves it's not just a simple thing of switching on a few lights or switching off a few lights. We have to plan it. We have to guide aircraft from A to B, route them correctly, and know where the aircraft is at all times. And this is just a diagram showing where AGL fits into that equation, where the field sensors to know where the aircraft is could come from a whole range of technologies, whether it's induction loops or radar, or etc. And we have to communicate that across into our, which we'll talk about, into our management system and air traffic control management system. And this is a nice little diagram which shows all the other technologies associated with surface movement guidance and where we fit into this equation. So all I'm said to at the time, for operational needs, do you think we can manage it? Do you think we can install it, design, install, and maintain these technologies? So let's have a look at some of the alternative technologies that are involved. And I'll start, and I'm not going to go into the detail of this, but I'll start off with just reminding ourselves, like, let's take a stop bar with lead on, lead off, and approaching a stop bar, and the circuits that we have. We have, and remembering that AGL electrical circuits are interleaved. So for every system, we must have a minimum of 2 circuits. And so lead on, taxiway center line, stop bar, all dualed up. And then you start to look at the number of circuits, you get 8 series circuits, plus 2 additional circuits for the lead off capability, because lead off, lead on lights have to be operated separately. And therefore, that's a lot of circuits, eh? And in this, look, there's no individual light control and monitoring, and there's no adjacent lamp fault diagnostic systems built into that. So that's a lot of circuits, a lot of cable, a lot of connectors, a lot of transformers, etc. Let's have a look at one particular company. They call it an Airfield Smart Power System. This is a typical application for this system, where they use addressable switching units and for the individual light control and monitoring, and they do some combination of enables them to do combinations of center line, lead on lights, etc. So here we start to look at the number of circuits which would be applicable in this particular technology. And the result being is 4 circuits only, including the lead-offs, and we have individual light control and monitoring, and there is adjacent lamp fault detection capability. So that is a major saving in infrastructure. And if we look at a typical dual stop bar scenario on an airfield, then, and we look at the traditional AGL, we have something like, in a dual stop bar with associated taxiways and lead on, lead off lights, we have something like 64 circuits, over 200,000 meters of primary cabling. That's one hell of a lot of infrastructure to either install or maintain. But if we go to the ASB system and we do these combinations, we can get it down in that same configuration to around 8 circuits and around just under 35,000. Now that is one heck of a saving. That means less cable, less connectors, fewer circuits. So overall, commercially attractive, maintenance attractive, installation simpler. So if you need any information associated, please contact this company, ADB SafeGate. I'm not going to go into the detail of the systems. So the summary of that is, between a traditional and the ASP, in a particular airport application, this is for real, then there was 84% cable reduction and 87% fewer circuits. Going on to another company, and this is where OCHEM had developed a 2.2 amp system. But what is slightly different view is the primary system. Primary system then operated at lower current, and whereby then there were step-up transformers for the light fixtures, so they did not have to change the light fixture configuration at all. So this was on the power and the distribution of the primary side. If you need details associated with that, please contact OCHEM. If you wish, we can provide their contact details. It's similar to ADB SafeGate. And going onwards to potentially a change of direction here, is we're dropping the concept of a 6.6 amp traditional circuit and looking at it completely. And so the way I explain this, and this is from TKH Airport Stroke and one of the subdivisions use technology, is SED, that's Contactless Energy and Data Distribution System. This is currently going through the IEC, so it will be built into the standards. And it has been around for quite a long time, but it's now being applied more actively into the AGL sector. And it is principally for the LEDs. It is not, and I repeat, not for tungsten halogen light fixtures, it's LED technology. And what that does is, instead, we actually drop completely the fact of needing a CCR. So there is a base station that will provide both power and communication. So basically, the way I explain this, instead of having the traditional 6.6 amp system, and we've tried to superimpose communication onto it, they come from a different direction. We have communication and superimposed power. And it's done by the space station and with a twisted pair cable, and that twisted pair cable just goes out in one loop and it's terminated at the end. And the light fixtures, which are called nodes, could even be sensors, and these nodes then are attached to this twisted pair via induction technology. And the system, if we want to put it into a practical AGL scenario, looks something like this. So if we want interleaving, every other light will come from a separate base station. And that base station then is through to its control master, and it is controlled via, and has to link and can link in via a traditional control system in one form or another on an airport. It also can feed into a maintenance management system because the capability of this said system is such that there are multiple functions on the communication side, reliable communications. And I've shown 3 pictures at the bottom here, which shows how the twisted pair cable is attached to an inset light, and it's by an inductive clamp. Very interesting. And so to summarize on this, the SED technology, then you don't need a CCR, you do not need transformer pits, you do not need connectors, we do not need isolating transformers. And so that's really interesting. So the physical civil infrastructure, there's got to be a major lower initial investment associated with it. And here it's said it's something around 20%. So obviously every project is going to be different. No connectors, so there's no galvanic contact with the cable. And that's an interesting, because what it means is we can actually change an inset light in the field on a live circuit because we're not breaking into the electrical circuit. So there's no major disruption to the process of going out into the field. We can do it in a shorter space of time. So there's some definitely operational savings in that respect. It also, because of the way the power is superimposed onto the system, is that there's 40% lower consumption for standard LEDs. That is quite a considerable power consumption saving. Therefore, if you don't have the infrastructure such as transformer bits, etc., then it's relatively easier to install. And what is important from a safety viewpoint, and remember safety is a major issue for us in the traditional AGL, is that the voltage on the system is below 1000 volts. So it takes us out of the high voltage safe working procedures regime. So we do not have to go through that authorized person scenario. And because of the way the communication system in the region of 20 kilohertz and its fast communication, the data transfer, the diagnostic capability associated, so we can even do predictive maintenance with a set system, and can link into, as I say, into any maintenance management system. So if we have an asset management tool, then it can link into that as well. So quite a lot of savings here, I would suggest. I would suggest. But what the key issue for me, I think, is comparing us to our traditional AGL, 6.6 AGL, and we've tried to superimpose over the years communication, and in many cases not too successfully, because we do have quite a lot of failures associated with the ILCMS surface movement guidance technology, where the core signal comes from, we've said, then it's going to be highly reliable in comparison. Which leads us then on to CDM, collaborative decision making. We are part of.
Hello, Keith. Keith?
Yes.
Nothing like a surprise, but I thought we have a couple of questions that have come in. So whilst we've just done that on the previous section, I will bring in Thor in a moment to ask his question in a first time live question attempt. But first of all, a question from Khaled L. Orr. He says, he asked, for the smart AFL, what about redundancy and 5 kilovolt circuits interleave?
But in terms of, in what respect is that question? Are we talking about the new technology of SED, or are we talking about the traditional, in terms of the traditional AGL circuit?
No, in terms of smart circuits, I wouldn't say specifically to any particular manufacturer, but how are they building in redundancy in the next generation of control and monitoring system?
Well, I think that is, whenever we take a traditional 6.6 amp system, then the power, the voltage that is going to be needed on a typical system is going to have voltages in the region up to 4,545 volt for a 30 kVA. Now that's going to pressurize, that's going to put a lot of pressure, electrical pressure onto a traditional circuit, primary circuit, including those connectors. Those connectors, that has not changed since we had 6.6.
Right. Khaled has just added here, because redundancy is IKO requirement, as well as the interleave between circuits for the same type, edge lights, for example. So that's what he's asking about there.
Is it what I'm asking is that what I'm saying is that in a traditional circuit we have interleaving. That means that every alternate light is on a separate circuit. That is where the redundancy comes in a traditional AGL system, whereby if you go to the new technology, these more recent technologies, the SEG technology, and you'll see from this diagram that I've just
I've lost you there, Keith. Keith, I can't hear you. Keith?
Sorry, I'm online.
Right, that's better. I can hear you now.
Okay.
No, I mean, basically, Keith, well, what we're saying is that these smart technologies do also feature interleaving. So that is how
yes.
they achieve redundancy.
That is
Specifically,
correct. All of them must be interleaved. Correct.
yeah. So, and a follow-up question, Khalid asks if smart technology is approved by ICAO. Well, smart. It is just new technology. It has to comply with ICAO, and the answer is that the new technologies are compliant with ICAO because
actually, ICAO do not specify how things have to be done in great detail. It is the IEC, or if you go into the FAA, it's through the FAA for the American. But in the international marketplace, it is the IEC, the International Electrotechnical Commission, and the technical standards. And for the new technologies, and well, let's take this technology, that is currently being written into the IEC document 61820. So the new issue of 61820 then will include the new technology.
Thank you, Keith. And Thor, we will now introduce Thor. If you can hear me now, could you ask your question? You're unmuted.
Is muted.
If you can unmute your phone, Thor. No, we can't hear Thor, but if you could put your question into the Q&A section, we'll come back to you later. We'll come back to it later. Okay? Okay, Keith, carry on, please.
Okay. So yeah, just to re-emphasize on this point, you know, what of the question and potentially, and maybe this is a similar vein that Thor is going to ask, is that it is mandatory that we build in redundancy. Now, it doesn't matter whose technology that we employ, then we need to ensure that should some of the lights go out, then the remainder of the lights stay on and the pattern remains uniform. It's as simple as that. So the technology must include that. And here is this picture on this particular solution. So I'll move on to collaborative decision making and where we fit into this wider platform of surface movement guidance control. There is a whole range of technologies and systems that are fed into a collaborative decision making platform. And down at the bottom here, I've shown here, we clearly are coming under the air traffic control and the airport operator scenario, where the airport operator is looking to reduce, get a reduction in the capacity, whereby in air traffic control, we've got the runway availability capacity, that's that traffic density issue I mentioned earlier, and advanced surface movement guidance. And so looking at the generic milestones associated with how we come in, an aircraft arrives, it gets turned around, and then it departs again. Then here we are. Look, we kind of, AGL fits into the approach and the landing area. And then we have to then transit to the parking position. And then after pushback, we then have to transit back to the runway where we enter the runway for takeoff. So there are some of these elements, all shown as stars, look, where we are actively participating in with surface movement guidance and control. And if we are going to use traditional technology or smart technology to provide information into this system, it has to be compliant and it has to be reliable. So I've just brought two of those elements into here. Look, the airport operator side and the air traffic control. These are pictures that have come from Eurocontrol, which operate the air traffic control system throughout Europe. And it links in with all the other air traffic control centers globally. And so our key message for everybody is all about safety, compliance, and competence. We are part of CNS with Advanced Surface Movement Guidance and communication, navigation, and surveillance. And this is a nice picture which actually defines it. This is, by the way, everyone, this presentation is available to you online after the webinar. So what I'm going to say is principally, you cannot manage that you cannot measure. So if we are going to use AGL as an input to surface movement guidance, as an input to collaborative decision making, then we designers, installation, commissioning engineers, and particularly maintenance, then we need to have the knowledge, the skill to be able to maintain and keep those systems operational. And, so we're back to compliance and competence issues. Do we have the technical competence to achieve operational compliance? And you need a tool. When you're looking at elements associated, you've got your infrastructure out in the field. You've got your runway systems, you've got your taxiway systems. Those runway systems, those taxiway systems have to be looked after and they have to be maintained. So they have to be correctly installed and commissioned. They have to be maintained. And to maintain them, you need tools and equipment. You need to have processes and procedures. You need to keep records. And above all, it's us, it's people that do it. So you need to have competent personnel. So you need to have some kind of asset management control system in place to be able to effectively demonstrate records. You need to demonstrate reliability. I mean, for example, what happens if a bolt comes loose in the field? Well, we regularly torque them. Well, if we can automatically record that, it would be great. We do photometric testing. If that's automatically recorded, we've got to keep them clean. The light fixtures clean. There's a whole range of maintenance tools associated. We need to package them into some kind of control system, asset management control system. And this is just a typical example of how that can be done. And so the tools are available to you. So there's no excuse. You can't say, oh, I didn't know. Oh, no, we don't have that. The tools are available. So let's ask you the same question again I always ask. Are you confident that you have the knowledge and the skill to be able to either install, commission, maintain, and as a regulator, are you aware of this? Are you really aware of it? Okay. You can only answer it to yourselves, or maybe your airport management needs to answer that question. So let's go on to electrical safety, because really now, if we go around the world, then some of the newer technologies are not yet introduced. We are still pretty much, as a majority of the world, it doesn't matter whether we are a big international airport, whether we are a regional airport, or a little small airfield, then when we're looking at AGL, the traditional way, the 6.6 amp system has been around for a long time, You have old infrastructure in many airports, and so that's deteriorating. And as we know, the more you use it, the more it deteriorates. So let's have a look at electrical safety. And there is a video. Now, I'm not going to show the video. Okay, it's available to you online. So when you go to click onto the TMS Training Solutions website for this webinar 4, this video is going to be available to you. It's an ideal electrical safety video. So, danger. We know there's danger with electricity, but what kind of electrician are you? Because when I grew up in an electrical world, it was all constant voltage. Nobody mentioned constant current. And it's only when I got into the airfield side and realized, hey, this is different. I don't have all these safety trips, etc., all built in. Then the lights are scheduled to burn wherever possible out in the airfield. And therefore, there's very few safety issues built into the system. There are some, but not so many. So we need to have an understanding. So there are hazards, eh? We need to isolate circuits. But sometimes we have to have a live circuit when we're testing. So we need to have processes for that scenario when we're working on energized equipment. The electrical test equipment, can we use the test equipment? Is it in date? There's lots of various tools associated. And do we have the correct PPE? Are we issued? Does your airport provide the correct PPE? And if they do you use it? And what about the work area? Well, we've all spoken about working safety airside. Going out in the airfield is a dangerous place. What happens when there's an electrical storm? Don't stay out there when there's an electrical storm, because you'll be one of the principal targets. So it's a whole range of considerations when we're talking about electrical safety. We need special training if we're going to work on a 6.6 amp circuit. And we need to be authorized and qualified to do so. So when we do authorized person kind of training for 6.6 amp, that is authorized persons in high voltage safe working procedures, voltages in excess of 1000 volts, then there are practices, which is the law in your country. We all have principally the same regulations involved with high voltage safe working procedures. Above, that is, voltages above 1000 volts. We need to isolate. We need to be able to earth the system down. In AGL, we have kilometers and kilometers and kilometers of primary cable. That, when it's operating, is just like a big capacitor. So even if we switch off a CCR, we have still got an electrical charge there. We need to be able to operate the test equipment and tools correctly, and as I said, have the correct PPE. So no person is to carry out any work when knowledge is necessary to prevent danger unless he has such knowledge or experience or is under a degree of supervision appropriate for the task. So there's an element. We can still work on AGL under supervision if we're not deemed competent. Remember, it's your life. It's your life. So know the hazards, know the equipment, use safe working practices, inspect your PPE before each time you use it. Crikey. I've had to go out now with this COVID issues with, the face mask. Can I drive with a face mask on? No, I wear glasses. Put a face mask on, steam comes up, glasses get steam, can't see where I'm going. So one element of, is your PPE fit for purpose? So do not work on energized circuit without permission and completing some kind of hazard or risk assessment. Now that is a requirement under the law, that you do a hazard or a risk assessment associated with working on a 6.6 amps AGL. So remember, we need you. We don't want you to get injured or killed. So what are hazards? Shock, explosion and burns. Just as I showed you earlier. No excuse for showing this again. The more you see it, the more you'll remember. So I will show you these pictures again, as I showed you at the beginning. I'll tell you when you get an electric shock, and I will ask you a question and ask it to yourself. Have you ever had an electric shock? That's a question. Answer it to yourself. And if the answer is yes, why did you get that electric shock? The answer for that is because you did something wrong. It's as simple and straightforward as that. So before starting work on AGL, de-energize, lock off, and test circuits to check that they're dead. Anything above 50 volts, that should be done. And we make sure the system is de-energized from all the potential power sources. And one of the things that we can have in AGL is cross feed between circuits. So that's why it's important to earth down. And do not rely on the air traffic controller to switch off for you. Please do not, because that is asking for trouble. So, lockdown. In the substation, make sure the incoming power to the CCRs are locked off at the isolation. If you do not have those lock-off capability in an old substation, make sure you have some kind of additional process in place. So a tag without a lock must be supplemented by at least one additional safety measure. That's what I'm saying to you, okay? Be careful. Ensure power is off and is isolated correctly. I've already mentioned the fact of earthing down the circuits. When you've gone through all this process of switching off, de-energizing, locking off, right, I am now safe, everything is great, I'll now put my fingers into the AGL circuit. No. Earth it down because of that capacitive effect. Okay, discharge the circuit. There's a video. I'm not going to show it now. Look at it afterwards. Nice little video. So principally, look, what we've done here is we've really covered working safely airside with the form of 2 videos, which hopefully you've had a look at. We've covered AGL in terms of the standards, the principles and the layouts, which includes having a look at just a brief element of runway-related lights, taxiway-related lights, elevated lights, inset lights, etc. There was a video associated with that, which hopefully you've looked at online, which is approach to and taxiing in Dublin International Airport in Ireland. It's an old video, but it brings the point home. Then we looked at the 3 elements of AGL: power, AGL, remote control. And today we've kind of looked at some of the aspects, the operational needs, the follow the green technology, and some of the technology changes that are available. Please, if you want any information on the technology advances or the alternative technology, please contact us, because we'll put you in touch with the relevant person in the relevant company that are providing them. Electrical safety, paramount. We want you to be safe. Okay, so please, any questions at all, here's our website, come back to us. And now we're going to ask 2 questions. Here, look, is a little bit on fault diagnosis. Now, these 2 questions, question 1 is about compliance. showing your knowledge. Do you have the understanding what happens when there are earths or open circuits or high voltage earths in your field circuit? That's up to you. Look at this question. It's on the website, and we'd love to hear from you. Answer it and send it back to us. We're not going to mention any names, but we'd love to have an understanding where they do actually appreciate. And this question, look at, there's points here, A, B, C, D, E, and F. And what we're saying, typically, look, question A, what will happen to each light in the circuit above if there's a direct short to Earth between A, where's A, and F? A direct short to Earth, Earth there and an Earth there. What happens to all those lights, 1 to 10? The next bit is B. What happens to each light in that circuit when there's a high resistance Earth at C and a short to Earth, direct short to Earth at D? So between high resistance Earth there, direct short to Earth there, what happens to the lights 1, 2, 3, 4, 5, 6, 7, 8, and 9 and 10? And question C, what will happen to each light in the circuit above if there's an Earth at B, and an open circuit at E? Now bear in mind, each of these points will probably be a connector out in the field or waiting to fail. It's as simple as that. So answer the question if you can. We'd love to hear from you, because if you do training courses with me on our competency training courses, AGL training courses of the various types, this is what you need to know and answer to be able to justify one of the questions, to be able to justify your competency. There's a second question, is about electrical. And there, look, is the second question is question 2 and 3, really, but and it's all about insulation resistance. Question 3 is about continuity resistance of your primary circuit. And there's a scenario in A, which is what will be the allowable earth leakage in a category 3 runway centerline with light fixtures installed in shallow bases and with a circuit having the following characteristics? Well, draw the circuit. Work out how long the primary circuit is from the substation all the way back to the substation. How many lights are? Bear in mind, the circuit is interleaved. Back to that redundancy element that's built, that was asked. And then, once you've got that information, what will be the minimum insulation resistance value for that particular circuit when you know what the allowable earth leakage is? And then question C is, what insulation resistance level would we set the CCR, the earth fault detection system on CCR? Remember, if there's a minimum acceptable level, we don't want to wait until minimum before we get an alarm. So what would you set it to? And also question D, what will be the actual insulation resistance reading during routine maintenance before you start maintenance? Now that's interesting. Then you might get an alarm level that you've set, which is above the minimum acceptable, but you may say, oh crikey, I don't want to wait until I get an alarm because my circuit's not going to, there's going to be a problem in the circuit. So you need to be able to have a process where you're taking readings, where you need to decide when you're going to do maintenance. So there's a consideration there. And the other aspect is that in ICAO standards, in the Aerodrome Design Manual Part 5, it calls for doing an insulation resistance check with a suitable insulation resistance tester, we commonly call the MEGA test, because Mega was the first company to do an insulation resistance tester of the appropriate type. And IKEA called for us to do it at 5,000 volts. However, if you've got old circuits, if you regularly test at 5,000 volts, then potentially you're going to overstress the old circuit, potentially. Therefore, we tend to, in maintenance, do it at 1,000 volts. We're still going to measure the insulation resistance, but of course the figure is going to be different. I equals V over R, Ohm's law. We can't change that. So if V is different, your insulation resistance figure is going to be different. So it's going to be pro rata. And then finally, what continuity resistance value with a multimeter would you expect to get on that circuit that we've discussed here? So here we are. It's two questions, two basic questions. One is an operational performance in terms of what happens to the lights. Do they go out? Do they go dim? Or do they go off? It's as simple as that. Out, dim, or off. Answer it that way. And this is an electrical problem, electrical question. Do you really understand what you're doing when you do an insulation resistance test? And why are you doing it? You're doing it to check whether the primary circuit is of the correct quality, because you do not want to get earths. Because if you get earths, as in question 1, some of the lights will go out, or dim, or they will flicker. So let's really come to the end of it there, Robert. I think...
Thank you, Keith. That's tremendous. Really useful. And I hope I've seen there's a number of questions coming in. We haven't got time to cover them all, but we will answer them in on our website. We'll provide the videos and also a copy of the presentation from today. Keith will also be providing copies of these two questions together with comprehensive answers, so you can test yourself and see how much you know. And if you get something wrong, hopefully we'll have the answer there. But of course, please feel free to contact Keith directly if there's something not clear or you need any help in any way. There's a number of questions coming in, but we're at the virtually at the end of time here. I'll just ask Paul Burners from Dublin has just asked, what is the safest way to discharge the built-up voltage once the AGL circuit is isolated, Keith?
You just do a direct short to earth with a piece of cable, right? So you're at the CCR, for example. You've isolated, you've shut down. The circuit is lock off, etc. We totally de-energized. The CCR is off, and then of course all you have to do then is to have a piece of electrical cable and to touch one side of the output of the CCR and directly to earth, and that will discharge. Or at the point of work where you are in the field. Right.
Okay. So thank you, Keith. As I said, there are a number of questions coming in now, which we will respond to on our website. I'd like to thank you first on behalf of us all for actually making that presentation and giving us all the knowledge and understanding which you've built up. As I said, if there is anything specific that people want to do, please email us or Keith directly, and I know he's always pleased to help you. So in his presentation, he's reminded us all about what a dangerous environment we're operating in. We saw that lovely Atrix video, which showed us how the individual light control and monitoring is working, and that's going to become standard as we move forward. We highlighted the unreliability of the traditional 6.6 amp systems connectors, but also how the new technology fits into surface movement guidance systems.
Could I
And,
just jump in there, Robert?
John?
Robert, could I just
Yes.
jump in there? I just want to, you know, I've highlighted really the connectors, you know, as potentially the single point of failure, you know, in the main single point of failure. I must add, though, the connector manufacturers have done some fantastic work to make the connectors more and more reliable over the years. So let's not forget the efforts that they've put in.
No, absolutely. But as ever, it's a personal view is that they are extremely good connectors, but you have to have the right training and the right tools to be able to use these connectors properly and efficiently to avoid any issues in the future, given these things are going to be lasting hopefully for tens of years. So
Well, it's very interesting, Robert. When it comes to that question about connectors, a few years ago I did a practical training course in one particular country where the airport management were involved with the training, and it was to put connectors together onto a primary cable, and the direct supervisors and the electricians who work on the field. And it was very interesting, the fact that everyone could theoretically know what to do and how to do it, but the electricians did it very well and put the connectors on ideally, very quickly. The supervisors took a bit longer. I think I'd still be waiting for the managers to finish their job.
and this,
you know, because it's about familiarity. This is the skill. Knowledge is okay, but you've got to have the skill. Eh?
and presumably this is presumably in a classroom, whereas of course the actual installation work is taking place often in very adverse weather conditions, in the pitch black, cold, wet, and the rest. So
Yes.
yes, it's not always an easy task, well, never an easy task even. So we talked about new technologies, addressable switching, ability to reduce the number of circuits, new technologies such as SED, and there are a number of questions relating to both, and we'll respond to those on the website. We've looked at collaborative decision making and how visual aids are integral to a system of CDM, and so our role is therefore integral to the next generation of aviation and gate-to-gate technologies. And then, of course, you recapped on the absolute basic requirements for electrical safety and electrical competence. And I think it's always good to test ourselves. And these questions you've posed here will be very, very useful. These are for all you electricians out there. These are things that Keith assures me you should know the answers to. So spend a few moments and test yourselves there. And of course, if you or any of your colleagues feel the need for some training, TMS Training Solutions will be more than happy. We'll provide generic training courses, and also we can put on a bespoke training course online or in person when conditions allow for your specific airport. Again, contact us through the website and we'd be delighted to help you. So what's next? Well, Keith and I discussed this. We've had a number of feedback questions from you out there, and it's fantastic that you seem to be so responsive and interested in what we're doing, and we really appreciate it. We don't take your participation for granted. So, based on the questions and the requests from our audience, we'll be next week putting on a short presentation followed with a panel discussion of experts on AGL installation and maintenance. It'll be next Tuesday at 2 o'clock, and we will publish details of the presentation and the panel in the next couple of days. Following that, we've been asked to do a session on airside asset management, and then finally, all good things come to an end. We will be doing a PAPI masterclass where Tony Smith and Keith and potentially others we're talking to will be participating. Tony will be doing a short presentation, and then we'll have a panel discussion again, covering any questions you might have about PAPIs. So, Keith, I think at this point, we're over time now. I think I'll close for the week. I'd like to thank you very much. Do you have anything to say?
Well, I just, you know, one of the things which I think is really important to mention now is that yesterday, for example, you know, we all work in aviation, and we know that it's a dangerous world. Aircraft are going all over the world and take off, landing, and do different functions. There's cargo aircraft, passenger aircraft, but there's also military applications. So don't forget the military side. And sadly here in the UK, so we're based in the UK, from Royal Air Force Lakenheath yesterday, the US Air Force operate from there, and they lost an F-15 fighter, part of the NATO in the North Sea, and sadly the pilot lost his life. So our condolences and sadness to his family.
Yes, absolutely, Keith. So we'll be back. We'll be back next week at the same time. We'll send out an itinerary, but it'll be AGL installation and maintenance. Thank you all for participating. And to use the words of, I was a Boy Scout when I was young, a long time ago, as we restart our aviation and try and recover back to start our route to recovery to normality, please be prepared. Thank you very much. All the best. Goodbye.